Good afternoon, everyone, and welcome to our Perfect Practice webinar, Big Data, Driving Innovation in Healthcare Storage. I'm your moderator, Nancy Roberts. This webinar is brought to you by National Physician Services, a charter member of the Perfect Practice Alliance. Our agenda for today's webinar is one we think you'll find of enormous importance to your information technology strategy. We'll begin today's session with a quick introduction to our host, National Physician Services, or NPS, and then we will introduce you to National Physician Services CEO Brian Graven, who will talk to you about their approach to managing data storage challenges presented by big data and talk about their exciting new partnership with Datrium. Next, Craig Nunes, Vice President of Marketing for Datrium, will give you a quick corporate overview of the company. And following that, Datrium's Mike McLaughlin will provide a quick product demonstration and give you more insight into how NPS through Datrium can help make big data less of a big headache and more of a big benefit to your practice. And finally, we'll wrap up with questions and answers from you. Now, because we want to make sure that your questions are answered, and we want to make you aware of how to ask a question at any time during this presentation. So what you want to do is locate this question box in your control panel, and at any time you have a question, simply type it in right here, and we will try to address all of your questions as we wrap up today's session during the question and answer. So let's start with a very brief introduction to National Physician Services, our host for today. NPS was founded by physicians and healthcare technology visionaries to provide innovative solutions for hospitals and medical practices across the country. NPS provides an end-to-end suite of healthcare information technology services, from CIO advisory consulting to disaster recovery planning, application support, and desktop services, up to and including comprehensive managed IT partnerships. For more information on NPS, visit our website at nationalphysicianservices.com. And now let me take just another moment to introduce today's panel. Brian Graven, CEO of National Physician Services, Craig Nunes, Vice President of Marketing for Datrium, and Mike McLaughlin, Director of Technical Marketing, also at Datrium. And now I'm very pleased to introduce Brian Graven, who will explain to you how big data is impacting data storage technology and requirements in healthcare, and how Datrium partnership came about, and why this collaboration can provide such an enormous advantage to healthcare provider organizations. Brian?
Thank you, Nancy, and good afternoon, everyone. So we all know that big data is growing in healthcare at epic proportions. And some of the reasons behind this significant growth is that everything is digitized, from your electronic health records to digital images, the labs, clinical analytics, genomics. The list goes on and on. Everything now is online and it's electronic. And with that said, the increase and the data demands on healthcare, are astronomical at this point, and growing, and will continue to grow, in the foreseeable future. I read an interesting, statistic recently by McKinsey Global Analysts, and they predicted between now and 2020 that healthcare data will grow by 35 zettabytes, and to put that in perspective, that's a 44% increase from where we are today. So the information is out there, and the need to manage your data, ensure that it has the reliance, has the speed and performance, so you can utilize it, so your providers can utilize it. It's critical. Here at NPS, we're here to address those challenges in the healthcare marketplace. We work with hospitals and physician practices on really fine-tuning and supporting the infrastructures, so you can run your clinical systems and ensure that you have the reliability, that there has the proper security. It's meeting all the regulatory requirements, because your infrastructure is essentially the lifeblood of your practice. Without a healthy infrastructure that delivers speed and performance, without the reliability, I see that as such a difference in between I guess a legacy or an outdated practice to a successful modern day practice. So at MPS we come up with solutions, whether they be in the cloud or on-premise solutions, to help practices and hospitals optimize their infrastructure. Our commitment is to really bring infrastructure services and many other services that allow the medical community to enhance patient care, maximize revenue, and ultimately become more efficient, and where they are today. Next slide, please, Nancy. So, in our goal to bring innovation to healthcare, we partnered recently with Datrium, and we're really excited about this partnership. Datrium is a on-premise solution that practices and hospitals can bring into their environment and make a significant difference. There are many reasons why we like this partnership with Datrium, but from a high-level perspective, it's a revolutionary product that delivers incredible performance. The speed, the management is outstanding, and it's all delivered at a lower cost. We see this as essentially a new category in storage. It's different from your traditional storage area networks. It's different from your traditional storage farms, and it could be a viable alternative to even going into the cloud, which I know a lot of healthcare organizations are starting to look at seriously and have already started that journey due to it being somewhat less expensive. So without sacrificing speed, without sacrificing the management and quality, we feel Datrium delivers all of this in a very robust, innovative on-premise solution. Next slide, Nancy. Thank you. So get to a few specifics as to why we like Datrium. And I'll say we're a big fan of Datrium. We actually use this for many of our practices already. We've started to put electronic health records on this storage platform. We have PAC systems, financial reporting. This is a storage platform that we are using today, and we are using it successfully. And this is only the beginning. And a couple of reasons why we bought into the Datrium model is that first and foremost, it delivers incredible speed. I think clinical providers, end users, really understand the need to have a storage platform that is fast to the end users. And it's not just fast; it's noticeably fast, which is a big difference. I think one of our physicians came up to me the other day, and they said, "Hey, Brian, I don't know what you guys did to the system, but it is faster than it's ever been." And when you get end user feedback like that, it's very positive. because this is something that definitely has had an impact on to our end users. We've been like many other organizations in that we've looked at hybrid arrays for storage as well, and this is half the cost of a hybrid array. So it delivers that performance at half the cost. Those are probably the two biggest separators between all of the advantages, but there's even more. It's also agnostic with your existing storage platform. So you can build off of your existing storage platform, and you can use different flash drives and other technologies. It's very complementary of everything. So you don't need to throw away what you have today. You can build off of it with Datrium. According to our engineers, they find using the storage platform that Datrium delivers way easier to manage. And we've taken resources and we've been able to divert them to other projects because the management of this storage network is much easier than the legacy SANs that we've had in house for many years. And the great thing about Datrium as well is as you continue to build off of and scale your environment with this technology, it gets faster. And I don't think you don't need to sacrifice speed anymore. You don't need to say, oh, this application is going to be faster than that application. No, this is all the same speed and performance, and it really takes a lot of the complexity out of all of the applications and what you need to give to them for CPU and RAM to ensure that they're all performing at their optimal level. So those are a few points right here as to why MPS has partnered with Datrium and why we like this technology so much. From our perspective, this is innovation at its finest. There are certain technologies that really come into play that change the game, and we believe this is one of them, and that's why we call this a new category in storage. So with that said, I'll turn it back over to you, Nancy.
All right, very good. And now we are going to actually turn the program over to Datrium, and I am going to have Craig Nunes give you a little high-level presentation about the company, and then we will actually get a demonstration.
Great. So, thank you, Nancy.
Okay.
And thank you, Brian, too, for that wonderful introduction. Hi, everyone. Again, this is Craig Nunes. I am Vice President of Marketing here at Datrium, and joining me today, Technical Marketing Ninja for our company, Mike McLaughlin. We have a super important topic for you today, and let me tell you why. Brian touched on it. 35 zettabytes of information. A zettabyte, guys, is 1,000,000 petabytes. The amount of that information literally would fill the Atlantic Ocean with bytes. It's a huge amount of data. And in the healthcare industry, electronic information in clinical systems is growing by as much as 40% a year. And a lot of that driven by the adoption of EMR in particular, and it's no wonder why data storage ranks as one of the top IT challenges for you guys. Maybe you've experienced storage-related performance issues that's threatened your doctor's productivity, your ability to ultimately serve patients. Budgets stretched thin to handle that data storage growth. More and more time required by you and your staff to maintain your SAN, making it difficult to maintain responsiveness and address other important projects. And if you're feeling any of these stresses, then buckle up, because what we're going to cover today, what Datrium has developed for folks like you, is this new category that Brian referenced, a breakthrough alternative to your SAN. Let's start by just double-clicking into the company so you get to know us a little bit. The founders here at Datrium were the legends behind a company called Data Domain, a wonderful storage company founded by Brian Biles. He was a founder and VP of Product. He's our CEO here at Datrium. Hugo Patterson, CTO at Data Domain, is our founder and CTO here at Datrium, and this is already another CTO at Data Domain. Two other founders were a couple of the top VP level engineers at VMware, Boris Weissman and Ganesh Venkatachalam. And in fact, several of the early engineers at VMware are now here at Datrium. And these two groups of people, data storage and VMware, were introduced to each other by a wonderful woman named Diane Green. She was the founder and CEO of VMware, who later, along with other VMware and Data Domain luminaries, became investors in our company. The chemistry that these two groups have brought together, data storage and virtualization, you will see has been really important in development of this category and product architecture we'll take you through. Now, the Datrium team took aim at capitalizing at this massive shift, this new wave cresting in our industry, the commoditization of compute, or x86 servers, which has created a revolution in server-based infrastructure like in-memory databases is a good one, where you're doing a lot of local reads instead of reads across the SAN. Network function virtualization is another good example. Software-defined networking, all of which are built on x86 servers versus network switches now. Okay, the founding team at Datrium predicted back in 2012 this shift would completely transform the face of storage to something we now call server-based or server-powered storage. So why server-powered storage? Why now? Why does it matter? Most of you are probably aware that flash is fundamentally transforming the requirements of applications like electronic health records, practice management, revenue cycle management. What you might not be aware of is the fact that flash is much lower cost on servers versus storage arrays. Why is that? Well, when you account for the fact that adding flash in an array often requires investment in drive chassis, fiber channel ports, sometimes controllers. There are different markups for flash on storage arrays. Flash on arrays can cost as much as 8 times more than flash on a server. Okay? Flash also performs better when located on the server because of its proximity to the application, to the VMs. And what the graphic on this slide shows is that the more cores and more virtual machines on a host, the more the simultaneous request for I/O, we call that queue depth, the more the SAN gets in the way of the application. And again, back to doctor productivity, those kinds of things get impacted when that happens. If you purchase an all-flash array with advertised sub-millisecond response time, again, as the number of cores increases, it's nearly impossible to maintain that level of latency. So here's the takeaway. Not only is it more expensive to get flash in an array, it's not going to perform for you. Datrium fundamentally is set about to solve this challenge for virtual machine-based storage, which frankly is 80% of all the workloads in the world. Now, before I turn it over to Mike, I want to address one important and interesting server-based storage alternative. It's been in the market now for a couple of years, and it's called hyper-converged systems. You might have heard of it. In this approach, everything's bundled together. Everything scales at the same time, both compute and capacity. Think speed and capacity. It's basically an array that also runs VMs, so every x86 server node does a combination of VM workloads and storage. There's an inherent simplicity, at least initially, with this model, but there's some very well written compromises out there. One is, if you lose a server, if a host goes down, it's like losing a storage controller all at the same time. So you've got all of a sudden not just application issues, but data risk. The bandwidth that goes into the host-to-host communication in a hyper-converged environment can really hammer your network and in some cases lead you down the path of a network replan. There are issues with neighbor noise, so one application or set of users impacting the performance of another application or set of users. Growth is expensive because, again, you can't just upgrade capacity or speed. You have to upgrade both at the same time, and few of your applications are going to scale that way. And one of the biggest complaints of all around hyperconverged is, by virtue of providing you this combined server storage node, it requires basically a rip and replace of your existing server environment. Who wants to do that? It doesn't plug and play with your existing infrastructure. So as I mentioned earlier, Datrium's developed a server-powered storage alternative to SAN, delivering many of the benefits of things like an all-flash array or hyperconverged systems, but without the compromises. So at this point, without further delay, let me turn it over to Mike, and he's going to take you through the Datrium approach in detail. Mike?
Okay. Thanks, Craig, and folks on the line and NPS for some time today. I'm the Director of Technical Marketing here at Datrium, and as part of my role, I get to work with the product, work with our customers, and sort of vet these things out. And we're going to take a little bit of a deep dive into the product here and a short demo. But the first thing I want to do is just spend one moment, and if there's a couple of things that you can take away from today, is we've introduced a solution that is architecturally has the potential to be faster than all-flash arrays, cheaper than hybrid arrays, and more flexible and easier to manage than the hyper-converged sort of all-in-one-box solution that Craig had just mentioned. So I'm going to touch on some points here that I hope help you understand how these three sort of high-level perspectives can be achieved. All right? So let's dig into how the product is actually architected. We deliver a piece of hardware, which there's actually going to be 4 terms on this slide that I want you to walk away with. The first one is the net shelf, very at the bottom, the net shelf appliance. This is the thing that we deliver to you. All right, this gets shipped, it gets into storage appliance. It looks very much mechanically like a storage array. It has disks in it, controllers, NVRAM, network connections, etc. But it serves a fundamentally different role in the overall solution. But this is going to provide us the durable capacity. And durable capacity is one of these things that I want you to think about, because that's the data that you produce day in and day out that you want to make sure that you don't lose. So you want that safe, you want that shared, you want that readily accessible. That goes on the net shelf. So think of durable capacity and the net shelf as sort of the thing that shows up in a box from Datrium. Now, we talk about server-powered storage. All right, speed is host resource. What we're going to do is leverage the hypervisors, the virtualization hosts in your environment, and we do this and scale this by essentially installing a hyperdriver through normal VMware mechanisms onto each host that wants to be part of the Datrium solution. All right. So the other term here, server-powered storage, is achieved by us installing a hyperdriver piece of software on each of your ESX hosts. And this essentially lets you scale sideways or scale out the performance of the storage in your environment. All right, and this is essentially done by simply installing the net shelf, introducing it to your environment, and then we will push the software up onto each of the hosts that wants to be part of that solution. All right, and we were able to basically scale this out. Now you'll see a couple of things. The durable data collects all of the writes, the data that you're creating in your environment, but we're essentially going to put server-level flash on the hosts at server-level prices, and that's where we're going to service all of the reads from. All right, and so this basically gives us an architectural change between a typical storage array, and possibly a hyperconverged solution. So we've done some benchmarking internally, and I want to just touch on these briefly because I think benchmarks are important to help you understand not only a performance envelope, but also the fundamental architecture underneath the solution. With a typical all-flash array, for example, you're going to go out and look at the all-flash array. It's going to have specifications on how much capacity it has, how fast it can go, and how much it costs. Those are usually the three drivers. All right, something, let's say, from Pure or EMC or any of the hybrid players that also have all-flash arrays, those all-flash systems are going to have some rated level of performance, and that's the red line in this diagram here. And it's not going to go above that. The more hosts you add, it's not going to go above that. Those hosts are going to divvy up or divide or share that aggregate spec'd out performance.
This chart shows what happens to the aggregate IOs per second in 32 KB IOs as we add hosts. I'll explain at the end how we have a lot of isolation and locality of IOs per host, but as you add hosts, it adds speed, and that's independent of how much you've actually stored. This also shows one of the knobs you have for optimization of quality of service. Because we use host cycles, if the hosts are faster with different clock speeds, or you apply more cores, it's a host with more cores, it actually produces more speed as you add the number of cores and clock rates. A typical all-flash array controller is shown in the red line at the bottom. So you can see how, if read speed is your interest, this is a very simple model to scale. But we make it also a little better in a different way. There are other techniques to modify speed dynamically. One is just coming out right now, and that's a software switch we'll demonstrate at the end of this discussion. Normal deployments, our sort of normal default is we use 20% of a host's cores for processing storage. With a software change, you can hit a button, it can go into what we call insane mode, where it uses 40% of a host's cores.
So now I have this ability to bring servers to my solution, and based on how I want to deploy those servers and use them, I can get more and more performance out of the overall system. So what does this mean? It means faster applications can be placed on servers with the right amount of horsepower. All right. Management of this environment is actually fairly simple. Once you introduce the net shelf, you basically are managing everything from inside a virtual center. We'll see that in the demo that I'm going to do in a couple of minutes. But also, if you think of things like performance management or noisy neighbors or allocation of resources, because my hosts can have different characteristics, they can have different CPU power and now different storage power. So I can essentially vMotion my applications around to the hosts that have the right resources to run them. So if I need more CPU, I find a resource in my environment that has more CPU. If I need more storage I/O, I either turn on the insane mode or I find a host in the environment that has the right resources and vMotion my application virtual machine onto that. So essentially we're at a per VM level view of the world now. So storage management now becomes a virtualization administrator's tool. All right, open up the toolbox, they can move things around. Storage becomes a way that they manage things, and they don't have to worry about either aggregated arrays or storage pools that are spread over across all of the nodes. It becomes a per host kind of resource that can be easily managed. All right. So I made this point in the earlier graph. This is just kind of another way to look at it. With traditional arrays, as I add hosts and add workload, I'm basically dividing or sharing the resources of that array. The array doesn't get slower, but the per host allocation becomes less and less and less as I add more to the environment. So at some point you sort of have to purchase arrays or configure them for where you think you're going to be going. You can't grow it economically as your environment grows. So as you add applications, as you add data, as applications become more important, with the Datrium solution, I can basically add hosts to maintain a linear kind of performance envelope for each of those hosts that I bring in. Okay. I made a point earlier about one of the key aspects to think about here, and that was the cost. Now, we've got flash on the hosts, that the hyperdriver is using. It's already a little cheaper than the flash you would get out on your all-flash storage array, and that's where you get your performance. But now the NetShelf itself brings that durable capacity. The NetShelf starts with 30 terabytes addressable. We have inline reduction and deduplication available on the hosts. We also do data reduction on the NetShelf itself. So capacity of that can be literally 100 terabytes in this 2U appliance that you install. And what we've seen is the cost of other sort of typical hybrid arrays, let's say from Tintri or from Nimble, that would have a similar capacity and performance envelope are typically about twice the cost of the Datrium solution. So we're getting a more cost-effective storage footprint as well as a higher performance envelope for application support. All right, and I mentioned the administration. All right, you're at the virtual machine sort of VM administrator's level. The way that we've designed the software, the way we've designed the application is to make sure that there's isolation between the nodes, between the ESX hosts. All right, so this hyperdriver installation comes up easily from the NetShelf. All right, it's installed on the ESX host. All right, and it's isolated so that each host operates independently. All right, this gives us the flexibility to manage the environment from everything from performance to data and failure isolation, as well as just, as we talked about earlier, vMotion, performance and locality. So each host now becomes an independent part of your environment. So you could imagine in your data center, you could have big BC production hosts and maybe more cost-effective dev test hosts or sort of second-tier app hosts. These things are all now part of what you can have control over by deploying the Datrium storage solution, this server-powered storage solution, into your environment. Okay, so what I want to do now is just segue for a minute. We're going to do a quick demo, and I'm going to come back to those points. Before I jump into the demo, I want to just take a minute and put a context around this because it's going to go fairly quick. We've got a couple of 5 minutes to work through this. I don't want to take all your time today, but the things we're going to look at is scalability within the Datrium solution, because I think this is a critical part. And there's essentially 3 ways you can do this. I can add more hosts to the solution, more server-powered storage, bring that to bear on the problem. I can choose more powerful hosts. So as I'm looking around in my current environment or planning future server purchases, I can look at hosts with faster or more cores that can be utilized for server-powered storage. Or I can go onto the hosts and flip them from the default fast mode over to insane mode and have them do more storage I/O. So we're going to do this quick demo, essentially walking through these 3 methods here. And the way that this is going to work is I'm going to start off with an environment with basically 3 ESX hosts. And the first host here is it's a 20-core host, a very typical thing you might find in your environment, a 2x10 system. And I'm going to run essentially 4 applications on here. What the applications are doing, they are trying to do I/O on this host. And I'm getting about 30,000 storage I/O out of this single host in our environment. You might say, well, that's actually pretty good, Mike, but I think we can do better. All right, I told you earlier, if I switch that into insane mode, I should be able to double up the storage performance of those applications. All right, if I deploy more hosts, so let's go get another one of these 20-core hosts and move one of my applications over to it with vMotion, I should be able to increase the storage performance of my overall solution. Again, we're not managing the individual app, the ESX host, or the array. We're looking at the server-powered storage systems as a whole. Let's flip that one into insane mode and double up there. And then at the last point of this demo that I want to get into, so I'm going to go get a beefier host. I'm going to get something with 32 core on it. All right? And to actually push this host, I'm going to need to move a couple of applications onto it because those 32 core already bring almost 50,000 IOPS to the table. And again, I'm going to push that into insane mode. So at the end of this demo, I'm basically going to take a single ESX host running Datrium and 4 applications, and if you remember, it was about 30,000 I/O, and move that up to over 200,000 IOPS spread across a couple of server-powered storage hosts in my environment. All right, so with that, let's jump into a little demo here. All right, and this will go a little fast. If you want more details at the end, feel free to reach out to us afterwards, but let's kind of walk through this. So the Datrium solution plugs right into your virtual center. Administration is easy. Here's my environment running about 30,000 storage I/O, and what I'm going to do is take a look at the hosts that are running in this environment. Now I'm doing this all from inside a virtual center, and we can see that this one host here is actually kind of maxed out. The other 2, if you look closely, we're sitting idle. If I drill into that host, that's of course where the I/O is coming from. The 30,000 IOPS are coming off that single host. We can see the virtual machines that they're running down there on the lower right, but we also see that it's running in fast mode. So let's click the insane button. All right. This is an on-the-fly, dynamic, no disruption to the environment. All we're doing at this point is taking more CPU horsepower from this host to run the storage I/O. And yeah, the screen did jiggle a little bit. That's not a transmission error. But what we see is we've jumped up to about 65,000 IOPS on this host. Take a real quick look inside that blue circle there. It was 30,000. It's now over 60,000. If we go back up to the top level of our environment where we see the overall picture, we see that the aggregate IOPS have gone up to 66,000. If anyone was paying attention a little bit earlier, that third screen over, which I did not point out, was at about 4 millisecond D average. And the D average is being measured at the virtual machine. It's not a storage component. It's not a network piece. It is what the virtual machines are seeing from a storage perspective. It's now dropped down to a little over 2. So by switching to insane mode on this host, I've also cut latency. Dropping latency, faster apps. More IOPS, faster apps. Very simple to do. All right. But if you remember what we saw a little earlier, the system had a couple of other hosts that were not deployed. All right. So what we want to do here is go back to that dashboard or that view of the hosts. Here's the 4 virtual machines. We see them all running on ESX01. All right. I'm going to vMotion one of those onto one of those idle hosts. All right. A very simple operation here. This is storage administration for the virtualization administrator. Find a faster host. Find another host. Add another host to your server-powered storage system. All right. This will take just a moment. That application, now these applications are all called perf host. Your applications will be different. You'll be doing clinical apps, you'll be doing patient apps, things like that, but they're all storage hungry, they're all compute hungry. We now see that we're actually at 90,000 IOPS on our aggregate top level dashboard. Quick math, 60,000 from the first server, 30,000 from the second server. If anyone's paying attention, that second server is not in insane mode yet. So let's go take a look. We see that it's running about half as fast as the top one. Aha, let's put it in insane mode. These are things that this is really the only Datrium storage operation that I have to do here, is choose how my host is running. All right, I'm going to click insane mode here again. We're going to see the screen shake a little bit. That's natural. And we're now running about 60,000 IOPS on this host. Our aggregate now is up to about 130. All right, this is all part of the server-powered storage solution. This is how we're getting the performance. We're bringing host CPU to bear on the storage problem. Now this next one's going to take just a minute. I've got 2 more applications that I want to basically move over to that third idle host. And while that's happening, and I click through these things, let's just remember we're doing this all from inside a virtual center. Storage has been allocated to these virtual machines the natural way administrators allocate storage to their VMs. There's no storage administration specific tasks, no RAID, no LUNs, no storage pools that have to be managed. The net shelf has been introduced to my virtual center and now becomes essentially a large storage resource across all of the hosts that are running the DVX hyperdriver. All right, so I've essentially moved those 2 over to my last ESX host that I have here. So I'm now nicely spread across 3 hosts. Let's see how things look. If anyone wants to do some quick math, we're running at 195. That's 60 plus 60 plus about 50-ish. I promised over 200,000 IOPS. All right, and what I want to do now is take that last host and click it into insane mode. All right, and this will just take 1 more minute here. We're going to click from fast to insane mode, and essentially now by picking hosts with more core, by distributing the workload across multiple server-powered storage hosts in my environment, and choosing insane mode, and this one right now is running nearly 100,000 IOPS itself. All right, I'm going to go back to the top level in my virtual center where the Datrium DVX is tallied up for all virtual machines, and we can see here that I'm running well over 200,000 IOPS from my storage. So back to those paying a little bit of attention, notice the DAVG latency. It's been dropping every time I bring more host to bear on the problem. And what was once running a little over 4 milliseconds and 30,000 IO, which isn't bad, is now running over 200,000 IOPS and sub-millisecond latencies on those reads. Again, faster I/O, faster apps. All right. That's about it for the live demo or the recorded demo that we have here. I'm going to switch back in just a moment here to the presentation. Bear with me one second. I'll click out of here. And because I want to just sum this up, all right? Faster than all flash arrays, bringing hosts to bear. Half the price of hybrid arrays. We really didn't talk too much about the data reduction, the deduplication, and compression that happens in the environment, but we're doing that on the host and on the net shelf, on the durable capacity. And more flexible than hyperconverged. What I just showed you here was a very simple example of how to deploy host and storage resources in your environment to basically solve the problems that you have without some of the constraints that you might have in a hyperconverged solution. All right. And I think with that, we can turn it back over to Nancy for any questions or a follow-up here.
Okay, that sounds great. That's a truly impressive demonstration of computing power, and we thank you very much for that. We do have a number of questions, but being time sensitive, I'm just going to field a few of them and then give you an opportunity to ask your questions directly. And if you have any specific questions, we'll also give you a contact for that. Now, first question, is this an alternative to my SAN? And if so, what if my SAN still has a few more years left on it?
Yeah, so this is server-powered storage. It's definitely an alternative to any of the storage you may have in place now. By bringing the net shelf in, this 2U storage appliance, adding that to your data center, you can now add flash storage to your hosts at server-level prices and bring the Datrium hyperdriver onto those hosts and play alongside with your existing storage. So if you still have some time on your storage, you can keep that in your environment, and then you can look at the critical applications that need performance or additional capacity or want to be part of the solution. V-motioning things like I did inside of the Datrium is a very natural thing for VM administrators to do. So we can coexist with existing storage platforms.
Okay. And if this, in fact, does replace my SAN, how big is the box? How much space is going to be taken up in my data center?
Okay, good question. So over the course of time, you may be moving your workloads or new workloads onto the Datrium solution. It's a 2U appliance. It has 30 terabytes addressable, so that's sort of the minimal you'll get out of it. What we're seeing in sort of real world is you're going to get 2 to sometimes over 5x reduction on that. So that footprint right now is somewhere 30 to 100 plus terabytes of capacity in your environment that you can now basically have durable data to up to 32 server-powered storage hosts.
Okay, what type of resources are needed to support the Datrium technology?
So I'm assuming you're talking about staff resources and the like. Once the net shelf is installed, which takes maybe about an hour, it weighs about 70 pounds to get into the rack and put on the network. Everything then is managed by your virtualization administrator. So in the environments, you probably already have somebody who understands the ESX hosts and managing the virtual machine. This is a natural extension for their skill set. I don't think you're going to require any dedicated storage staff or storage admins. Like I said, there's no RAID, LUNs, pools, zones to worry about. Once you introduce the hypervisor, you have access to it as if you were managing VMs.
Okay, I'll give you one last question here in the interest of time. What exactly gets installed on the host?
Good question. So on the host, you're going to need to install some flash drives if they don't already exist. So we do want flash storage on the host that we can basically leverage for the front-end piece of this, for the read. So you'll need to install flash drives if they don't exist, and then once the host is introduced to the net shelf through the virtual center, we will install through the installation bundle mechanism a software bib on each host, which then essentially presents that net shelf as a shared storage asset, a data store. So the thing that gets installed is an installation bundle. It's not in the kernel. It's not a separate virtual machine. We take care of all of the mechanisms. You basically configure the host, and we will show you a Datrium data store capable of what I just showed you in the demo.
Great. Well, I'm sure there are many more questions, and we just can't take them all at the moment, so we're going to have to wrap up there. And with that, I do want to say thank you very much to our panel, to Brian Graven, to Craig Nunes, and to Mike McLaughlin for being with us today and for that information and insight. And we want to thank all of our attendees for being with us as well. Now, if you have any further questions or you'd like to set up a brief introductory call to review your current data storage environment and ongoing needs, please contact Tony Cincagrono at National Physician Services using that phone number you see on the screen or the email address. Thank you again for your time today. We look forward to hosting you again at an upcoming Perfect Practice webinar. Have a great afternoon.